Okay, so today we're talking about solving equations. Um, and the big thing about solving equations are these three big rules here. If you know these three rules, any equation that you try to solve becomes infinitely easier. All right? So, the first rule, and it's like the fundamental rule with solving an equation, is that you can do anything you want to that equation so long as you do it to both sides. What you need to try to think of an equation as is more like a balance. All right, you're putting um, one expression on one side of the equal sign and then you're putting another expression on the other side of the equal sign. So when you do something to one side, it sort of throws the equation out of balance, and you have to do the same thing to the other side to bring it back into balance. The second rule of solving an equation is that the equal sign divides the equation like a balance. So just like I said there before, that equal sign sort of acts as like a little fulcrum for your equation, and that whatever's on the left side has to be exactly equal to the other side or it doesn't work. Um, and then the final rule is a plus or a minus sign creates separate terms in these equations. So um, if you look, say, at this example that I have here, 2x plus 5 is equal to 19, what you have are three separate terms. You have the 19, you have the 5, and then you have the 2x. All right? So if you're looking at this equation, you can kind of balance it. You can kind of think of it as imbalance. You can put your little fulcrum right here. This is your fulcrum, and here is your equation. All right, so this 2x plus 5 is perfectly balanced by this 19, but on the left side you have two different terms, whereas on the right side you only have one term. So on the left side you can kind of divide this up even further into two little terms. Okay, so the goal here is going to be to get this x completely by itself. So we have to get rid of the plus 5 and the 2 here. So that's going to come into play when we actually solve an equation. But if you know those three rules, then you're going to be pretty good with solving equations. The only other thing to know about solving equations is what we call inverse operations. We have four operations in math that we typically use. There's the plus, the minus, the times, and the divide. So what you need to do is get into the habit of thinking of opposites. So this plus here is going to be undone by a minus. So if you had like a plus 3, to undo it, you would minus 3. If you had a minus 3, to undo it, you would plus 3. If you had something times 3, then to undo it, you would have to divide by 3. And then finally, if you're dividing by 3, then you have to multiply by 3 to undo that. All right. So if you know those few things, then solving equations will be in a breeze. So let's look at a few examples, and then we'll be done with this video, and you can move on and try to do some practice on your own. The first example up here, we have x plus 5 is equal to 13. So what I like to do when I'm solving equations, and I'll do this in a different color, is I'll draw a line here by my equal sign, so I know that that's where this equation is in balance. That's the balancing point for this equation. And now I'm going to have to undo some stuff. So I'll put a little line here. All right. The goal here is to get this x by itself. Okay. So in order to do that, we have to get rid of this plus 5 right here. So this is the term we've got to get rid of. And to get rid of it, remember, if we go back to the little rules I said here in this other slide, if we have a plus, we're going to undo it with a minus. So we have a plus 5. So if I want to get rid of that 5, I've got to minus 5 right here. Now notice, if you think about this being on a little fulcrum, I just put a minus 5 on this side, so it's throwing this side up. In order to bring that back into balance, I have to minus 5 on this side as well. Okay, so what that does is, what happens here is this plus 5, if we add them up and down in columns, plus 5 minus 5 is actually equal to 0. So my answer here, if we add up and down in these columns, I'll have x here left over. This will go away, and you don't have to write plus 0 there unless you want to, but you're left with x there. Our equal sign comes down, and now we just do this operation, and we'll be done. So 13 minus 5 will equal 8. All right, and this is your final answer. X is equal to 8. We have x by itself. We have a number over here. Everything's in balance. All right. Same sort of thing will apply over here when we're trying to solve this one. We have y minus 8 is equal to 4. So what I'm going to do, I'll draw my little line here. I'll cross it. All right, I look here. This is what I'm trying to isolate. I'm trying to get y by itself. So I have to undo this operation. I've got a minus 8 here, and if you go back to those rules, I won't bring it up again. But if you go back there, the opposite of minus is plus. So what we'll do is we'll plus 8 on this side. And then notice I just threw it off balance again. If we put our little fulcrum here, that 8's throwing it off balance. So to balance it again, I have to put 8 over here on this side. So then I'll add up and down in the little columns that I have here, and I'm left with y here. Minus 8 plus 8 is 0, so we can just cross that off. And then 4 plus 8 is 12. So my final answer here is y is equal to 12. All right. Same type of thing applies when we're talking about multiplication and division. All right. It's the same deal. The goal is still to get our variable, whatever letter it is, by itself. So right here, there's my dividing line for this equation. Since I'm not adding or subtracting, I won't draw that little line underneath it. Notice in math, when we have these two, a letter and a number, butted up against each other like this, what that means is this is 2 times z. All right, that's just standard notation for math. So we've got to multiply here. To undo a multiply, I must divide. But again, I've just divided by 2 on this side. To balance it out, I have to divide by 2 on this side as well. So what actually happens here, why this works, is because this 2 divided by 2 is actually equal to 1, right? So you're going to have 1z left over here. And in math, we don't write the 1 just because it's standard. It's assumed that that's a 1 if there's no number there. So we're left with z on this side, and then we just have to do this operation. 24 divided by 2, z is equal to 12, and that is our answer. And then finally over on this side again, here's my equal sign. Here's the variable that I'm trying to isolate. I've got x divided by 9 is equal to 4. So to get rid of that divide by 9, what I need to do is multiply by 9 on this side. And notice what happens there, and the reason why that works is because now we're on a diagonal. This 9 will divide by this 9 and equal 1. But I've multiplied by 9 here. I have to multiply by 9 on this side, and what I'm left with over here, these 9s will cancel, and x is equal to 4 times 9 is 36. So that's the basics of solving equations. Those are just one-step equations. I hope that helps. Thanks.